Welcome to your new unit, Circle Geometry. Today we're looking at Chapter 10, Topic 1, Exploring Angles in a Circle. So let's just start by familiarizing ourselves with some of the terminology that we'll be using. So the first one is a chord, and a chord is a line segment with both endpoints on a circle. So if we go from one end of the circle to the other, we have, voila, a chord. So we'll just write that in. And based on the definition, would a diameter be considered a chord if we were to draw that in? Well, when we think about it, if we were to draw in the diameter, does it go from one end of the circle to the other? Yeah, absolutely. It just happens to cross through the center. So a diameter is a chord. Next term is a central angle. An essential angle is an angle formed by two radii of a circle. So if we draw in one radius coming from center C to the edge of the circle and draw in a second radius, we have now created here a central angle. An inscribed angle is an angle formed by two chords with a common endpoint. So if we look at the chord that we drew first in black, and we simply name one of the endpoints, let's call it A, and I will draw another chord starting from point A on the circle, we have now created an inscribed angle. The last term is an arc, and then the arc is a portion of the circumference of a circle. So reminding ourselves that the circumference is kind of like the perimeter of a circle. So it's just going around that edge of our circle. So an arc would be perhaps what I've just highlighted there. So considering an arc, how many arcs would there be in a circle? Hopefully your answer is infinite. Moving on. Inscribed angles subtended from the same arc are congruent. Sounds a little confusing, but let's just break that down. So let's just start with an arc. So if we indicate two particular points on my circle, we'll call these A, B. So right here I have arc AB, and then I will indicate point D on my circle and point E on my circle, and let's also put in a point F on the circle. So if I draw an inscribed angle, so from point D to point B, there's one inscribed angle. We'll draw a second inscribed angle. Sorry, the pen's not really cooperating with the points I want it to hit. From point F, what we recognize, or what we should recognize if we were to take a protractor and measure, is that angle ADB is equal or congruent to angle AEB right here. And if I continue with point F on the circle and I draw another inscribed angle forming angle AFB, guess what? That angle also has the same measure. So that's what we're referring to when we say inscribed angles subtended from the same arc, so extended from the same arc, are congruent. Take a look at this example here. So we have arc MR and two inscribed angles, angle MNR and angle MPR, subtended from that same arc. Now take a look at these measurements here. So if I shift around point R, and even while those angles are changing, they are always equal. Let's now look at the next part of exploring angles in the circle. The measure of an inscribed angle is half the measure of essential angle subtended from the same arc. So once again, let's set out 2 points that will be kind of our boundaries for our arc or our endpoints, and we'll call those once again A and B. So we'll start with our central angle. So remembering that your central angle is made up of 2 radii. So here's my central angle, angle ACB, and we'll plot another point up here, and we'll call this D. And so we will make angle ADB our inscribed angle subtended from the same arc, from arc AB. And following the statement, and if we were to take a protractor, we would see that if we were to measure angle ACB, it would be twice or double the measure of angle ADB. Again, if we were to draw another point to the side here, we'll call this point E, and draw another inscribed angle subtending from that same arc AB. Once again, how does this angle AEB compare to that central angle ACB subtending from that same arc? Well, angle ACB will be twice that of angle E. So if we were to label the measure of angle AEB as X, angle ADB would also measure X, and angle ACB would measure 2X. Again, now we're looking at a screenshot from Geometry Sketchpad on which I have taken central angle BOC subtended from arc BC, and inscribed angle BAC also subtended from arc BC. And so taking a look here at those 2 measurements, BAC being our inscribed angle, and notice that it is in fact half the measure of the central angle BOC. And so once again, if I was to take one of these points and move it, pay attention to the measurements of those angles, and note that that central angle is always going to be double that of the inscribed angle. And that's essentially it for today's lesson. So remember that this is out of your textbook, chapter 10. On these pages, page 378, 385, you'll see some examples. Remember to have a look at the highlighted terms as well as the key ideas, that little blue or big blue box that is right before the homework questions. And your homework, of course there's homework, are these questions right there, and those are included in your unit plan that you were sent before. So if you have questions, certainly take a look at the lessons. They can be replayed. Talk to Miss Elston or Mrs. Adam or Miss Bertram or one of the other math teachers. Take a look at the textbook or have a look on the internet for some additional examples. A reminder that your test will happen a couple of days after I return, so you are expected to take a look at these particular concepts and learn them to the best of your ability. Okay, good luck, and we'll see you soon.